I gave an AI a real ABAP requirement, an ALV report reading purchase orders, summing by vendor, with authorization checks. No hints, no handholding. Some of what it generated was genuinely faster than I'd write it myself. Some of it would have passed the syntax check, moved through transport, and silently exposed data in production. I'm going to show you exactly where the line is, and why knowing that line is what makes you valuable when your company starts pushing AI into ABAP development. Here's the spec I gave it. Word for word what a consultant would drop in a ticket. Read open purchase orders from EKKO and EKPO. Some net value by vendor. Respect the user's purchasing org authorization. Output an interactive ELV grid. That's a real deliverable. I'm running this in an ABAP trial system with dummy data, not a client environment, so we're clean on that. And I'm going to review the output the same way I'd review a junior developer's PR. Structure first, logic second, security and performance last, because that's where the expensive bugs hide. Let's see what comes back. All right, first pass. The structure is actually solid. It went straight for EKKO and EKPO with a proper join, not two separate selects. It used a field list instead of select. That alone tells me it's seen enough ABAP linting rules to know that select is a red flag. The ELV is built with consolvable, which is the modern approach. It didn't reach for the old REUSELV SBLAY function module. And it wrapped everything in a class with a constructor and a run method. So it's not a 2003 era flat report. For boilerplate, for remembering the right class name, the right table join sequence, the basic ELV setup ceremony. This is genuinely faster than me on a blank screen. I'd estimate it saved 15 to 20 minutes on the skeleton. That part is real. But here's where a senior developer's review starts to earn its keep. Now the part that matters. 3 problems, in order of how dangerous they are. Problem 1. No authorization check. The select reads every open PO across all purchasing orgs. In a real system, that violates EKPO, the authorization object that controls which purchasing org a user can see. The AI didn't add authority check anywhere. This compiles, runs, and returns data the user was never supposed to see. You wouldn't find it in unit testing. You'd find it in a security audit, or worse, when a buyer calls asking why they can see Berlin's POs from Sao Paulo. Problem 2. Select inside a loop. The vendor summarization logic runs a select for each vendor in a loop. On the demo system with 50 rows, it's invisible. In a production client with 200,000 open POs across 3,000 vendors, that's 3,000 database round trips where one would do. This is the classic N+1 problem, and it's the kind of thing that brings a batch job from 2 minutes to 4 hours. Again, it compiles. It passes syntax check. It goes through QA on a small dataset and nobody notices. Problem 3. A field that doesn't exist. It referenced a field in EKPO that isn't there, probably hallucinated from a similar table. This one at least fails fast. Activation error, you catch it immediately. But notice the order. The field that doesn't exist is the safest bug because it's loud. The authorization gap and the performance bomb are quiet. They pass every gate and wait for production. That asymmetry, AI errors that are silent versus errors that are loud, is the thing to internalize. Bug 1. Missing authority check. This runs and exposes data select Ebeln Lifner Netter from EKKO into table at data, EKPO. Fix. Add before select authority check object bestEKKO ID EKKORG field LVEKKORG ID CE field 03. If SY subrc 0. Raise exception type XNO authority. Endif. ABAP. New DB call per vendor until value where Lifner equals vendor. Endloop. So what's the actual takeaway? Not AI is useless. The skeleton it produced was real value. Not AI replaces you, because it clearly doesn't understand your authorization model, your data volumes, or what EKKO and EKPO mean in a purchase-to-pay process. The pattern I see, AI is a fast junior. A smart one, but a junior who has never worked in your system, never seen a security audit finding, and has no intuition about what a million-row table does to a select in a loop. The functional knowledge, why bestEKKO exists, what the purchasing org authorization is protecting, Why the PO data volume is what it is, that's not in the code. That's in the business process. That's exactly the gap. And that gap is what makes you valuable when your company adds AI to the ABAP workflow. Not writing faster, reviewing intelligently. Knowing that a correct-looking authorization section that doesn't call authority check is a data exposure waiting to happen. The developers who understand the functional layer, the process, the EKKO/EKPO relationship, the authorization objects that sit behind each transaction. Those are the ones who can use AI as a multiplier instead of a liability. Which, by the way, is what the Functional for ABAP series is built for. That's next. Quick recap before you go. AI generated a structurally sound ABAP report in under a minute. It got the tables right, the ELV class right, the basic organization right. It missed authorization checks, built a select inside a loop, and invented a field. The first two are invisible until production. That's the real risk profile of AI-generated ABAP today. Pause it once. If your team is starting to use AI in ABAP development, or you're being asked to evaluate whether that's safe to do. I work with dev teams on exactly this, setting up the review layer so you get the speed without the silent bugs. The link to talk about that is in the description. And the next video is what every ABAP developer must know about the tables, the flow, the authorization objects. So the AI can't fool you on the functional layer. Subscribe and you'll have it when it drops. AI escriva/EU EKKO bug. AI wrote ABAP with no authority check. It compiled. Full breakdown in the video, link in bio. 50 rows, fine. 200K rows, 3000 DB calls. The full AI versus ABAP test is in the channel. Would have broken in production. I gave an AI a real ABAP requirement. Silently exposed data in production. Como revisor código gerado por IA. I work with dev teams on exactly this. Link in the description. AI wrote ABAP with no authority check. It compiled. Imagine this. Your AI generates an ABAP report that reads all purchase orders across every purchasing organization. The code is structurally sound. It compiles. It passes syntax check. It moves through transport. In production, a buyer from Sao Paulo pulls data from Berlin, data they were never authorized to see. Nobody notices until the security audit. The bug? No authority check statement against Investico. And here's the danger. The code looks right. The missing authorization is invisible until it matters. Full breakdown in the main video, link in bio. If your team is bringing AI into ABAP, knowing the difference between a bug that fails fast and a bug that fails in production is what makes you valuable. 50 rows, fine. 200K rows, 3000 DB calls. AI-generated ABAP with a select inside a loop for vendor summarization. On the sandbox system with 50 purchase orders, it runs in milliseconds. On production with 200,000 open POs, you're making 3,000 individual database calls instead of one. The report that took 2 minutes becomes 4 hours, or it times out entirely and locks the database. The code is syntactically correct. No error message. Just a performance bomb waiting to explode. The full AI versus ABAP test is in the channel. Understanding these 3 bug classes is how you use AI as a multiplier instead of a liability.